Welcome to VMware vSAN Deploy and Manage course. Now we are in fifth module, vSAN Policies and Virtual Machines. In the last video, we talked about the physical network requirement and the vSAN cluster requirement. Then we configured physical network and the vSAN cluster. Then we verified, we tested, we validated the platform is ready for VM workloads. But all these videos I didn't told you about how the high availability is managed, how the VMware, how the virtual machines manage high availability, and also how it tolerate with the failures. This is managed based upon the storage policies applied to the virtual machine. The main objective of this module is to explain how storage policies work with vSAN, and we will go through a demonstration of how to create virtual machine storage policies and how to define it, how to apply it, how to modify on while virtual machines are running. Then we will discuss about vSAN sparse snapshot format, and also we'll explain us about the consideration for vSAN sparse snapshot. Before we start explaining about the storage policy, I would like to make sure that you have a clear idea about how VMware vSAN is working. So VMware vSAN is a distributed RAID concept which aggregate the local storage devices. In our lab example, we had two SAS disk for capacity tier, each of 20 GB size, and we had 4 EXSI hosts. All combines together and give you 160 GB. So there is no disk allows as a parity disk or for high availability or for mirror. Every disk will take part in the vSAN data store and will give you a total space as a vSAN data store. So the important point that I want to notice you is when you buy a server, it come up with a RAID controller. So usually there is a doubt, do I need to configure a RAID on the storage controller? The answer is no, you are not allowed to configure any RAID level on the storage controller, because the VM high availability or the disk failures are managed through the storage policies by vSAN cluster. So the RAID controller of your EXSI host have no role in managing the high availability or the disk failure of EXSI host vSAN cluster. So the storage controller which you have when you're gonna buy a server, you have to make sure that the storage controller will support pass-through or HBA or JBOD mode, because EXSI perform the operations directly on the disk. So whenever there is a hard disk failure in your legacy storage or legacy servers, what will happen? The RAID controller will manage through the hot spare or through the parity disk. Here, if there is a hard disk failure, the vSAN cluster will manage this, and the high availability of the virtual machines will be managed through storage policy, because the storage policies are applied to the virtual machine, not to the logical disk. So, in case if your server doesn't have a pass-through or HBA or JBOD mode storage controller, you can go for a 1:1 relationship RAID 0, which means each disk you have to create as a separate RAID 0 and make sure it appear as a single disk to EXSI host, so you can create a vSAN cluster on top of it. So what is a VMware vSAN storage policy? We can simply say performance and availability of a virtual machine in a vSAN is defined by storage policy. So if you want high performance for a virtual machine, you can define it through storage policy. If you care about the capacity, that also you need to define through the storage policy. So by this way, you get a flexibility to manage virtual machines with the different performance capabilities, different availability capabilities in a single vSAN data store. So you don't need to worry about what kind of data store or where my virtual machine is running. If you want high availability, you can apply the different storage policy to virtual machine. If you want less performance virtual machine, then you can configure it to the virtual machine, not to the virtual SAN data store. So you are not worried about what are the other machines running. So this brings a flexibility and ease of operation for your day-to-day task. Let us start from the default storage policy of VMware vSAN. For that, go to menu and click policies and profile, and from here go to VM storage policies, then click vSAN default storage policy. Here you can see the rules that are applied to the virtual machine which have a default storage policy. So when you create a virtual machine, you can select which storage policy that you want to apply. So if you have different policies for different kind of virtual machines, you can select from it. For now we are discussing the default storage policy. So the first one is which storage type. It's vSAN. And then you can see site disaster tolerance method. It is a standard cluster. So if you go and edit, you can see the other options here. The other options are a structured cluster, and this will be discussed when we explain about structured cluster. So now we will stick on a standard cluster. The next one is failures to tolerate. So the first one showing here, like one failure is the number of failures it can tolerate. For example, one EXSI failed, or two EXSI failures, or three EXSI failures. So this is the maximum number of failures which a virtual machine can tolerate from the configuration here. The next one, RAID 1. It is the method which it used to tolerate. So a virtual machine can tolerate for one failure either with RAID 1 or RAID 5, or a virtual machine can tolerate with two failures with RAID 1 or RAID 6, or a virtual machine can tolerate up to three failures with RAID 1. So based upon the choice here, the consumption of capacity will increase. For example, if a virtual machine is configured for one failure and RAID 1 mirroring, then it consumes 200% of the virtual machine VMDK size. If a virtual machine is configured to tolerate one failure with a RAID 5 method, then it will consume 133.33% of the VMDK size. If we go for a two failures with a RAID 1 mirroring method, then it consumes 300% of the size of VMDK. For the final method, three failures to tolerate, the virtual machine will consume a storage space of 400 GB, because in a RAID 1 it keep mirrored copy of VMDK. So for three failures it keep 4 copy of VMDK file. That's why the consumption increased to 400%. In two failures it keep 3 copy of VMDK. That is why 100 GB VMDK size, it will consume 300 GB in a vSAN data store. Then it can tolerate for two failures. Next, go to advanced policy rules. Look at the first one, number of disk strips per object. This capability defines the number of physical disks across which each replica of storage object, which is VMDK, is stripped. Following are the values available for a number of disk strips. For example, I set disk stripe 2. Then you can see the picture here, stripe 1A and stripe 1B. So this is stripes of VMD. Next is IOPS. IOPS limit for object is a new quality of service capability introduced with vSAN 6.2. So this allows us to ensure that an object, here it is VMDK, does not generate more than a predefined number of IO operations per second. So by this way we ensure that a noisy neighbor, the one who uses more IO operations, does not impact other virtual machine components in the same disk group by consuming more than its fair share of resource. Next is flash read cache reservation. You can see near to that percentage icon is showing. So this is the capability only applicable to hybrid vSAN configuration, By this way we can reserve an amount of flash capacity for virtual machines which this storage policy is applied. So here, if for example you have a 1 terabyte cache device and you reserve 1% of it, it means 10 GB is reserved for that particular virtual machines. So if you have 5 virtual machines with this storage policy and you give here a 1% of 1 terabyte cache device, then this 5 virtual machines will get 10 gigabit as a reserved cache. Uh, the point to note is that you don't need to set a reservation actually to allow a storage object to use a particular amount of cache, because all VMs equally share the read cache for cache devices. All VMs equally share the read cache of cache devices. So the reservation, you can use it when you want to really test the performance improvement by increasing the cache or something like that. But generally you can keep it as untouched. Next is object space reservation. All objects in a VMware vSAN are thin provisioned. So here you can specify the percentage. You can define the percentage of a logical size of a VM storage object that need to be reserved during the initialization. For example, if I put 25%, initially reserved storage space for 100 GB VMDK will be 75 GB. If I reserve 50%, it will be 150, and if I put thick provisioned, it will be like 300 GB. So this is how the object space reservation is working. So generally you need to use thin provisioning only. Next is forced provisioning. Once you enable forced provisioning, then you are saying that the virtual machine can be provisioned even if the requirement specified in the VM storage policy has not met. So for example, you put failure to tolerance is equal to 1, but vSAN data store doesn't have enough space, and in the storage policy you enabled forced provisioning. Then it attempt a much simpler placement with the requirements which reduce to number of failures to tolerate 0, and also number of disk stripes per object. If it is 1 2, it will try to reduce it. It will try to reduce cache reservation. So it will try all this way and try to provision the virtual machine. You can apply this if the virtual machine is a non-critical one. The final one is object checksum. By default it is enabled, and this is something which looking for a data corruption. If it found, it automatically corrects it. And the checksum is validated on the complete IO path, which means that when writing a data, the checksum is calculated and automatically stored. Upon a read, the checksum of the data is again validated, and if there is a mismatch, the data are repaired. So if you want, you can disable it, but it's recommended to keep as it is. So we were talking about the default storage policy. I'm going to cancel it. I'm not going to make any changes here. And let us see the disk placement of virtual machine. From the VMware vSphere web client Adobe Flash, go to host and clusters, then select virtual machine. From here go to monitor and click on policies. So here you can see the placement of hard disk. So this is a RAID 1, and one VMDK is at host 2, and another VMDK at host 3, and a witness running at host 4. So this is how the VMDKs are placed. Now let us go and change the policy of a VMDK. So I'm going to edit this. And here I will change the disk stripes to 2. Then click next and finish. Here it is asking me, do I want to apply this policy to the running virtual machine, because this VM storage policy is used by one virtual machine. So it is asking me, do you want to apply this virtual machine policy to the current running virtual machines? I would like to say yes. Then click yes. Then you can see a reconfiguration of virtual machine has been applied. And the component has splitted as we see in the picture. For example, it's reconfiguring actually. Now you can see the disk stripes. It is striped the disk into um, host 4 and host 1 and host 3 and host 2 as a RAID component. So this is how the changes, you can apply the changes while the virtual machine is running. So now we changed the disk stripes into 2 and the storage policy has applied while the virtual machine is running. So this will not affect the service availability of your workloads. You can change your storage policy and you can apply while the virtual machine is on flight. So this is how you can verify the placement. Now let us go back and change the disk stripes into this default storage policy settings. I give 1, then click next and finish. So I would like to say now, click yes. Now let us see how to create a new VM storage policy. To create a new VM storage policy, go to menu and click policies and profiles, then go to VM storage policy, then you can just click and clone this policy. So we can create, by this way we can create a new VM storage policy. So I'm just keeping the same name to understand the new VM storage policy, and this is applying for vSAN storage, and here it's same, the standard cluster, the failure I just put 1. Then let's go to advanced policy rules and keep like 3 disk stripes per object. Then let us put force provisioning, some changes compared to the default storage policy. So it is same, you can edit either the default storage policy, or if you have different tier of virtual machines, then you can create a new storage policy. So you can apply based upon the performance and availability requirement, you can apply the storage policies to virtual machines. For example, you select a rule here, then if the data store is not compatible with that rule, then it will not show you here. So here I choose RAID 5. RAID 5 is applicable only for all flash. So the vSAN storage we have is a hybrid architecture, so it will show there is a now compatible storage is available. Let's go back and change it to the normal one. Okay, so our vSAN data store is compatible for RAID 1 only. So click next, finish. So now we have a new VM storage policy. So I'm going to create a virtual machine with this storage policy. For that, click here, add a new virtual machine, create a new virtual machine to the same data store, new virtual machine, and I just select host 1, click next. I select vSAN data store. You can see here VM storage policy. So here I'm going to apply new VM storage policy. This is what we just created. So new VM storage policy, this is the compatible storage vSAN data store, and the data store locally attached data store is not compatible for vSAN. So just select vSAN data store, then click next. Go with the latest one. It is a Windows Server 2012. Then click finish. So the installation of virtual machine is progressing. Let us go and see the disk placement now. So the second virtual machine, go to the monitor and take policy. Here you can see the placement is inside RAID 1, there is a RAID 0 and a RAID another 0, and the components are striped across following host. As the stripes are leveraged into a different host, this will help to improve the performance because it will provide more IOPS during the write operations. Let us move to the final topic in this module, VMware vSAN snapshot. What is a snapshot? We can say a snapshot is a copy of virtual machine disk file VMDK at a given point in time. So by this way, it keep a change log of virtual disk and it give you an opportunity either to restore the virtual machine to a particular point in time, or you can consolidate the changes and you can create a single virtual machine and continue operations. Look at the picture. Before you take a snapshot, the first one, a virtual machine write to the base disk, read and write operation will go to the base disk. Once you take a snapshot, look at the second picture. The base disk will act as a read-only disk and the new writes and read will go to the snapshot disk. We can call it as a delta disk. So when you want to read old data in the base disk, it will read from the base disk. And when you write something new, it will go to the snapshot disk or delta disk. You can go for as many as snapshots you require. Once you complete your update and once you feel comfortable with the changes, you have an option to go back by consolidating the entire changes and bring it as a single base disk. Or if you fail with some updates, you want to neglect the last changes, then you can decline the last changes and you can consolidate and can come up with a comfortable operational virtual machine. We learned about what is a snapshot. Now we are going to see vsanSparse snapshot. The goal of this technology or this kind of snapshot is to improve the performance using the same mechanism what we explained in the previous slide. But in addition to that, what it do, it utilize a in-memory metadata cache. It will be more efficient to handle snapshot and its performance. As you see before, it take a snapshot of the basic disk and a child disk is created. So now the parent is considered as a point in time copy and the running point of virtual machine is the change disk or means the delta disk. So all the new writes will go from the virtual machine to the delta disk, but the base disk still is used for a read purpose. So it only satisfy with the read. And you can go to the previous state by just consolidating all the snapshot, all the delta changes, and you will get your virtual machine back. So this is very similar to what the previous snapshot I explained. So the only change is it is utilizing a memory, a in-memory read cache. So what happened when you write something from the virtual machine to the snapshot disk, it will update this in the vsanSparse driver also. So it keep in a read cache in the in-memory. So whenever there is a request for the same data, the read cache will point, okay, the data is located in the snapshot 1 or snapshot 2 or snapshot 3 disk. So this is the advantage. But what about a case when there is a cache miss? At this time, this have to go and check all the delta disk and base disk the similar way we explained in the previous slide. Then there will be a IO latency. So this will improve the performance of snapshot by keeping a read cache. The important point is this is an in-memory read cache. This means the cache is placed on in-memory, not on the flash disk or rotating magnetic disk. So when EXSI host is off, then you lost the memory. You have to recreate, like how a swap works. Next is how a vSphere administrator manage this. It is same way. There is nothing new to do here. There is no selection process. Okay, I'm going for vsanSparse format or I'm going for the traditional vSAN. No, nothing like that. If the vSAN version is supporting vsanSparse snapshot, then you can go for it. This is automatically used. There are some consideration for the administrators who plan to use vSanSparse format for the snapshot. RAID cache reservation concept is one of the important thing, because in a hybrid deployment this may lead to higher than normal consumption of RAID cache resources. So always need to keep an eye on vSAN capacity and vSAN data store capacity consumption, because creating on a snapshot in vSAN create a vSAN object, right, and which in turn consume vSAN data store capacity. So capacity is the most important thing, that you keep an eye on it always and make sure that this is not hitting the maximum capacity threshold level. Then the retention period of a snapshot was like 24 to 72 hours before, but here you can keep it as long as you want. But if you want to keep it for long, make sure you regularly check the RAID cache usage and vSAN data store capacity. VMware support a full maximum chain length of 32 snapshot with vsanSparse snapshot, but it is advisable, however, not to exceed more than 16 snapshot delta per chain. And that is all about this module. I know this module was a very long module for you, but this is the most important module that when it, because in this module we covered about storage policies, how the storage policies are working and how the snapshots are working. So this is the most important module in VMware vSAN. And thanks for watching this video. Continue with the next module.